This talk will give us insights into the latest developments, emerging trends, and cutting-edge technologies in the transportation sector. Today, the ninth talk in this series will be delivered by Mr. Indranil Bose, Consultant, World Bank, on the topic Climate and Disaster Risk-Informed Transport Planning, Roads and Waterways. Now, I would like to invite our Director, Dr. Samson Matthew, to deliver the welcome speech.
Good morning and good evening to Indranil Bose. Welcome all of you to this TransTech talk series. It is in the ninth of this series. We have started this talk series in the month of February 2023, and every time we are getting experts and the authority, the people in this area, either through research or through their experience in the transportation related sectors. Today we have with us Mr. Bose, who is a World Bank consultant and with a lot of experience. In fact, when I was looking to his background, I was very much excited because he is with a civil engineering background and then an MBA degree. With that, he is working in the sector, the transport sector. And today's topic is also it is very relevant, especially to the state of Kerala and in India or in the world in general, because this is the need or the relevant topic for the current the transport sector. I welcome Mr. Bose to this TransTech talk series. Thank you for accepting our invitation. I welcome you to this program. In fact, this is a late evening for you, and at your busy schedule, you accepted our invitation. Thank you, and welcome you to this program. I welcome all of you. We will get faculty, students, research scholars, experts, and the field engineers from not only from Kerala. We used to get participants from all over India and sometimes international participants also. Since it is, we are arranging that one in a hybrid mode, and many are permitted to join through online. I welcome all of you to this TransTech talk series. Today I am at Bangalore. Because of that one, I'm not in a position to attend physically from the NATPAC. Welcome once again, all of you, and thank you for joining this our session.
Thank you, sir. Now I would like to invite Sri Ashik K. Azad, Junior Scientist, Information Liaison and Training Division, NATPAC, to introduce our distinguished speaker for today's session.
Thank you, ma'am. A very warm welcome to one and all present here today. It's with great pleasure that I stand before you today to introduce our distinguished speaker for this technical talk, an individual whose expertise and insights promise to enlighten and inspire us all. Mr. Indranil Bose is a civil engineer from Institute of Engineering, Science and Technology, Shibpur, West Bengal, and has did his MBA in finance from Indian Institute of Management, Calcutta. He has more than 25 years of professional experience in transport management and engineering advisory. He currently works as an independent transport expert, advising multinational development banks and consulting firms. As part of India's long-term low-carbon development strategy, he was involved in the implementation of National Waterways Program in India, developing Eastern Regional Waterway Grid and River Navigation Organization for BVI nations with a vision to increase transport modal share of waterways and improve the overall financing ecosystem of the inland water transport sector. In his current engagements in 2017 with the likes of the World Bank, the Asian Development Bank, and the other development partners, he has been significantly focusing on achieving climate adaptation and mitigation mainstreaming in the transportation sector. Ladies and gentlemen, it's my honor to present to you to the speaker whose expertise knows no bounds, the trailblazer and a true luminary in the field of transportation. Please join me in extending a warm welcome to Mr. Indranil Bose as we embark on this enlightening journey of knowledge sharing. Over to you, Mr. Indranil. Thank you. Hello.
Should I start?
Yeah, please.
Yeah. Thank you, for the sake of a good transmission, and I will put my video off, but I will take you through the slides, so slides will be visible. So, first of all, thanks, NATPAC, for inviting me for this talk. And I also welcome all the participants from various fields. And I hope this talk would be worthwhile for you. This is a very important topic in today's world, as we see climate change is a reality for all of us now, and globally, we see a large number of natural disasters year after impact, and we hear about large numbers in terms of the losses and the damages. So this topic is seminal, and there is obviously a need to plan, develop, and maintain the infrastructure in a manner that factors the historical as well as future climate risk and disasters. So the topic is about that. The way the way I've structured this talk is that I will first present some statistics about the disaster at the global and as well as India, and then come to a local context in terms of the 2018 Kerala floods and landslide. This will give you some perspective of the numbers, that we are talking about if we are not planning our infrastructure as resilient infrastructure. So that to begin with. And then I will touch upon the Sendai framework, which actually encompasses the disaster risk reduction strategy, and which was brought in 2015 by United Nations. Then I will decode some of the concepts of climate risks, disaster impacts, loss, damage, and the overall concept of resilience, because at times resilience is not very well understood among the engineers. Resilience, by resilience, we not only mean about asset resilience, we also currently talking of community resilience, we are talking about systematic resilience, we are talking about institutional resilience, fiscal resilience. So I will bring these concepts into today's talk, so that this becomes very clear, because once we are into the planning, we should look at not only asset resilience, but resilience in the entire landscape. So that's what I'm also going to give. And in order to give a more detailed perspective of how to go about climate and disaster risk informed planning, why is it important for transport sector? I will showcase some of the relevant statistics as well as information about the global learnings from transport sector resilience that we have found from various works from World Bank and ADB across the globe, and also demonstrate maybe through some case examples. One of the case example would be that of a road which. Hello.
Yeah, we can hear you.
Yeah. One of the examples would be that of a road which is being developed under World Bank and other multilateral funding in Kerala, which is the Alappuzha Chenganassery road, where we have gone about doing both asset resilience and community resilience in a very structured manner. So I'll introduce to you the case study of that road, and also touch upon briefly about the challenges that we see in IWT sector, and IWT sector being one of the greener mode of transport. It is important to make it even further resilient, so that this can be not only be adaptive to climate change, but also serve as the purpose of mitigation of the climate change in terms of reducing the carbon emissions, because we all know road transport tends to be more carbon emitting than waterways. So I like to acknowledge that some of the slides that I used are from my work with various development agencies and other consultants. And so probably you may have seen some of the slides over the course of. Now, just to give a perspective of what we are looking at and what is at stake. So IPCC, which is the UN body which does climate science, They have recently stated in the report that greenhouse gas emissions, especially the fossil fuels, are causing harmful changes in Earth's normal climate, and that's a fact. The World Meteorological Organization Atlas of Mortality and Economic Losses from Weather, it shows that there is a dramatic increase in. Hello, I'm getting some feedback. Can you meet the participants, please? Hello.
Yes. We had muted.
Yeah. So there is a dramatic increase in the economic losses over the last 50 years. The relative economic loss has been largest in the biggest countries like US, China, and India. But in terms of relative economic loss, it's highest in small island nations in Africa. A single hurricane can reduce the country's annual GDP by up to 800%. This is from observations in states like in the Caribbean countries. In Africa, a drought or a flooding event have led to an annual GDP reduction of almost like 20%. So this scale is huge. So the problem is huge, and we need to address it in a more informed manner. So globally, the focus has more been on mitigation. So, but now most of the development agencies as well as the government is also focusing equally on climate adaptation, and several of the development financing institutes are now committing 50% of their climate financing on adaptation, which is about resilience building. Now I will give you some perspective about the scale of disaster. Like in 2000 to 2019, India witnessed around 321 such natural disasters. China's 577, the highest. USA 467. Now, if you look at the way it has progressed over the 1980 to 1999, vis-a-vis 2000 to 2029, we see there is almost a 74% increase in the number of reported disasters. And in terms of economic losses, it has increased by 82%. So the scale is huge. If you look at the type of disasters, you will see three types. One is the extreme temperature. There is an increase of almost like 32% from 1980, 99, so 20 years block, to 2000 to 2029, to 2019. 234% of increase in number of flood incidents, and almost like 148% increase in the large landslide incidents. When we talk about Kerala disaster, it's a mix of flood and landslide. Probably there has been 400 landslide. Here I'm talking about large landslides, big hill slips and all. In terms of economic losses, if you see flood, 47% of the total disaster damage loss, and then storm. So these are the two most critical of the hazards that we have to tackle. This gives a perspective of the India scenario. The India scenario, as you can very well understand, is not very good. We as India, we are in a high climate risk index, and India, as per German index, is ranked very high on this. As per recent report, it shows that in 2029, India had almost suffered a loss of almost like 69 billion from extreme weather events. So the problem is huge, and we need to kind of address it. Now let me look at the Kerala flood and landslide. It will give you a perspective of what was at stake in that event. So it was triggered by a extremely high rainfall, which led to severe flooding and landslide. Almost like 5.4 million people got impacted. There was a large-scale rescue and relief of operations which saved many lives. Almost like 1.4 million people lived in 5,600 relief camps. And to sum it up, road assets were the worst impacted. And as you would know that road transport is a major mode of transport in Kerala. and it got worst affected with 25% of the total recovery estimates of 4.4 billion of the overall reconstruction cost. I will come to the overall concept of recovery a little later, because these concepts are very important to understand if you want to build resilience. You know, some pictures from Kerala floods, pictures are self-explanatory. I'm not explaining them. These are all captured, as part of the post-disaster need assessment that I was as part of the central post-disaster need assessment team. So this was in 2018, and this is a recent post-disaster need assessment that we did for Himachal Pradesh. Again, a huge, disaster leading to a loss of almost like 3 billion, which are, unofficial figures. Now, let us look at the framework which is available, in order to, so globally, the Sendai framework was worked out in 2015, and this is applicable for a 15-year period between 2015 to 2020, which is and targeted at kind of achieving the various SDG goals. This is, however, non-binding agreement, and there are 4 priorities of action and 7 global targets. But implementation of this framework needs strong commitment and political leadership from individual governments. So essentially, the 4 priorities are, to understand. Unless you understand the risk, you cannot act. So understanding risk is priority number 1. Then strengthening the disaster risk governance and to manage the disaster risk. So this is essentially about a landscape approach and overall bringing the institutional resilience part of it. Investing in disaster risk reduction, which is about the fiscal resilience. Unless you have climate funds or dedicated government budgets, you cannot have investments in climate resilience, adaptation, and enhancing disaster risk preparedness for effective response. So this is about, during maintenance, emergency operations, how prepared you are in the events of disaster. The overall targets, are to reduce mortality, reduce the number of people affected, reduce the economic loss, the losses, the numbers that I projected, reduce that, and to reduce the damage to the critical infrastructure. Some infrastructures are very critical or strategic, which needs to be more resilient than, maybe lesser strategic roads. Rural road might not need the same level of resilience compared to a strategic road, which connects to the probably, the international borders. The overall, target is also to increase the countries to have their own disaster risk resilience strategies, international cooperation to developing countries, and availability and access to multi-hazard early warning systems and disaster risk information. Now I will introduce to you some of the basic concepts of disaster. So a disaster generally has 4 dimensions. One is the damage to the infrastructure and physical assets. The other is the disruption of access to goods and services, disruption to governance and decision-making process. And once a disaster impact strikes infrastructure asset, it becomes more vulnerable. A weak bridge collapses. A not so weak bridge maybe becomes susceptible to collapsing once the next disaster strikes. So the other very important aspects of a post-disaster scenario is damage, loss, and recovery. I need to introduce this 2-3 terms to understand this, to make this talk more fruitful. So in terms of concepts, the damage is a kind of asset concept, right? So basically, when a hazard strikes a infrastructure, there is a total or partial destruction of the infrastructure, and the cost estimated for replacing or repairing at the market price is the damage cost. Similarly, the loss is the economic loss, and it's a kind of flow concept where the loss is actually the loss in the economic flows arising from the disaster, which, for example, a rural road which gets disconnected because of a flood impact for 10-15 days, and the agriculture produce cannot be moved to the market, the loss that it suffers in terms of foregone income opportunities is the loss that has to be accounted. The last very important concept, which is again a post-disaster concept, is recovery. Now, once we have a damage and a loss, you have to recover from that incident. The recovery is about reconstruction of the physical asset, resumption of production of goods and services and access to the goods and services, restoration of governance and decision-making process, and overall risk reduction and building back better. So here comes the concept of resilience. When we talk about building back better, we are talking about improving the resilience of the asset and the systems as a whole. Now, let us look at the concept of risk. Now, here we are talking about climate and disaster risk, which is a function of hazard, exposure, and vulnerability. Now, by hazard, we mean the probability and intensity of occurrence of a damaging event in terms of frequency and severity. So, probably, high intensity rainfall is a hazard. A flash flood is a hazard, whereas exposure is, degree to which infrastructure asset or community is subjected to that hazard. So that's exposure. And vulnerability is, in terms of its susceptibility to suffer loss or damage. A weak bridge is more susceptible to a damage, so it's more vulnerable. A rural road is more susceptible to a flood event, so it's more vulnerable. So a combination of hazard, exposure, and vulnerability actually determines the risk of the asset. So a location with a high hazard, low exposure, and a high vulnerability might be having very less risk, and the vice versa. So this is the definition that we have in which is used by United Nations. This is the resilience is defined as the ability of individuals, households, communities, cities, systems to prevent, resist, absorb, adapt, respond, and recover positively, efficiently, effectively when faced with a wide range of risk. So if you look at in the figure on the right, you will see there is a functionality of an asset. The red is an asset which is of high resilience, and if you look at the resilience triangle, it's a low resilience triangle, whereas an asset with a low resilience will have a high resilience triangle, which means low resilience would lead to high damage and high loss. Now, a new organization, CDRI, which is an international organization, has been formed by the PM of India, and this is a recently formed organization in 2019. In their recent report launched in October 2023, they have come up with a host of concepts about infrastructure resilience. So here it's been talked about in two terms. One is resilient infrastructure and the infrastructure for resilience. Now, resilient infrastructure is about two aspects. One is asset resilience and the service resilience, whereas infrastructure for resilience is to make the infrastructure developed in such a way that it enables a social and economic resilience and also provide system resilience. And what is very important and walks through all the resilience of both resilient infrastructure and infrastructure for resilience is the infrastructure governance and the fiscal resilience. So when we are talking of resilient infrastructure, the asset resilient refers to the ability of the assets to adjust to a disaster risk or a climate change, whereas the service resilience refers to the capacity of an asset to allow continuity of service provision, rapid recovery, or adaptation to be safe to fail. This means that in case you have 2 points, say A and B, connected by 3 roads, and one is a village road and the other 2 are state highways, and these 2 points needs to be connected even in a disaster event, then you have to have at least the state highway functional. There might be a break of connectivity in the rural roads. So that is what we mean by service resilience. Whereas social and economic resilience means how we bring about a change in the entire community resilience. An asset might be resilient, but it might create flooding of the community living alongside the road. Asset, in terms of the overall gaps in infrastructure of India vis-a-vis developed countries, we know that there has to be a per capita bridging of that gap in terms of the asset type. Some of the assets might need more investment compared to the others. So this is what is meant by social and economic resilience. And systemic resilience means, any resilient effort should be such that it should not create habitation or biodiversity loss. So that is the reason, there has been a lot of focus on nature-based solutions, hybrid solutions, which includes both engineering as well as non-engineering efforts. Now, in order to make this resilience work, there has to be a system resilience. Now, by system resilience, we mean, the ability to plan, finance, design, implement, having, systems like road asset management system for a road sector, IWT asset management system for a IWT sector. So this kind of systems and the overall institutional capacity to understand, plan and design infrastructure better. Fiscal resilience, is no brainer. It's about, ability to kind of garner financing to kind of absorb the additional cost which is required to build resilience. Now, let me come to some of the global experiences of transport sector resilience planning. Why this is important? Because this gives us a perspective of how to go about resilience. Resilience is not only about 30% more cost to what you would have normally done. It can be strategic. It can be very focused on and unless you understand the risk, you cannot do that. So some of the global learnings that what we see is that resilient climate adapted transport infrastructure tends to be expensive, but not by much. Say, for example, a road which needs to be provided with good drainage might cost 1% or 2% more, but not much. So that's not much. Even there is a huge uncertainty in terms of the climate change and its impact. So you cannot actually make a infrastructure resilient for high degrees of uncertainty. So there has to be an optimal design approach. Now, the overall, once we make the, if you look at the point number 3, despite higher cost, if we increasing resilience is always cost effective and it has a high benefit cost ratio. So that's the learning. Maintenance, as we all know, and we have always been promoting as part of bank missions, that this is fundamental to a resilient and reliable transport infrastructure systems. Investment on good maintenance of roads has economic returns of almost like 50 to 60%. Vis-a-vis new roads, not even 10 to 15%. Now, focusing on resilient transport services is also can achieve resilience. You might not have a very good road, but you might have a very good transport and bus system which can still operate in event of a flood. So that's what needs to be focused at. So connecting people, connecting dots is what is important. Planning for transport asset failure and for rapid recovery. Some assets will fail. We cannot always design rural roads in that it won't fail. So how we can plan for a rapid recovery is what matters. A bridge might be designed for 100 years return period, but a culvert might be only designed for a 10-year return period, and every 10 years it might fail. So it has to be such that the culvert can be installed in maybe 1 or 2 days so that the services are restored. A lot of use of digital technology to understand the risk. There are a lot of remote sensing which is done to understand the risk perspective, flood projections. Even these are currently used for post-disaster need assessment. So a lot of use. And last but not the least, and I think is the most important, is the use of nature-based solutions. Now, in terms of the stepwise approach for risk-informed planning, it can be, it has to start with defining the objectives. Now, for a strategic road, the objective would be quite different from that of a non-strategic road. So, it depends on the category of road, category of assets, and the overall risk, which is again a function of hazard, vulnerability, and exposure. Now, very important to understand the overall macro picture of the climate hazards. So getting this information from disaster management authorities, various websites, secondary websites, which give projected hazard details. So important to collect and kind of map it. Not only not only the historical but the future. So that's what projected climate hazard. What I mean by projected climate hazard. Investigation and evaluate options. So maybe an entire road, you can have the same system of resilience walk at all the sections, but some sections might be more having more climate risk and needs more targeted interventions. So targeted interventions overall would make the cost lesser and have a higher benefit cost ratio. So you have to plan your interventions accordingly. Now, on the right side, you see the 5 pillars. When we talk of resilience, we tend to only talk about resilience during planning and design, but we leave aside the other important life cycle phase, which is the operation maintenance, contingency programming, which is more about post-disaster management, and the overall institutional capacity and coordination. And this is the focus. Now, in terms of road assets, it has various sub-assets, like you have structures, you have drainage, you have geotechnical features, and each of these elements are designed for a different life. So how you would design an entire network so that it's still operational? So that's the target. So say, for example, you design a road for 50 to 20 years, but probably you would still design the structures for 100 years because it's a costly infrastructure. You would need to provide more for it, maybe more for foundation design so that it withstands a flood and erosion by the flowing river. So in terms of drainage, as I mentioned, maybe a 22% increase in the overall drainage interventions might overall reduce the susceptibility of the asset. Geotechnical risks are major risks which we see in disasters, at least what I've seen in HP as well as in Kerala. And this needs to be based on very focused understanding and geotechnical studies. Now, moving to a systematic approach to risk-informed planning is the way for the future. We have targeted this in Kerala PWD, where we have tried to develop a road asset management system which is climate informed. The first step of doing that is to map the assets and then follow with understanding the risk of these assets in terms of overall the hazard mapping as well as the vulnerability of the assets if the structures are weak. So overall mapping of this asset and also collecting the various climate information like the historical rainfall and temperature data. Based on that, you can actually develop a climate risk and vulnerability assessment based on this multi-criteria, which has all these factors. Once we have a very good understanding, macro level understanding of which all road network are important in terms of strategic connectivity, which are more vulnerable, we can go about the doing the site-specific assessment of the high-risk road and bridge assets, which can be followed by the cost-benefit assessment of the various resilience options. And the focus, as I mentioned, should be on hybrid solutions. Now, road resilience engineering generally has to focus more on value engineering and life cycle approach. The factors that you see on the left, location, rainfall, gradient, materials, these are important factors which we consider in the engineering designs. All these factors are important, and special emphasis on nature-based solutions as they reduce the systematic risk, risk of habitat loss, as well as overall increasing the carbon footprint. Use of local and marginal materials, recycling, low carbon intensive construction techniques are the way for the future. And it's always good to have a local resilient guideline that embeds local considerations. So local technologies differ, nature-based solutions differ across, maybe, coconut piles are used in Kerala, but coconut piles may not never be used in Madhya Pradesh. So I think having a local resilient guideline is very important. These are some of the local and global data sources that you have for, for various risks, hazards and risks, like the landslide risk maps, flood hazard maps. These are available, like global flood hazard maps at a certain resolution. These are both available on free as well as on chargeable basis if you want to get this flood hazard maps at a higher resolution. Here you have a 10-meter resolution flood map. These are, climate change scenarios, which will give you a kind of projected, annual, temperature or, precipitation, the intensity. These are factors which can be built in when we are designing for future. Some of the aspects are also needs to be captured as part of the overall PWD machinery. So disaster data collection, some of the disaster data might need to be collected in terms of, the extent of disaster, what is that kind of debris which had to be removed, for how many days, the road was closed because of this landslide. So this gives an overall understanding of the risk rating of that particular location. Similarly for flood, similarly for coastal erosion. So these are some tools which needs to be developed in the system to understand the disaster better. So unless we have the information, we cannot do that. So now let me kind of, since we have now discussed the overall concepts, let me look at the AC road, where we had tried to build the overall asset and community resilience. So this was a road which traditionally was, suffering annually 15 to 20 days of flooding, and this was a very important road connecting two of the major districts. It is located in the rice bowl of the state, and you see, there are various community resilient features which were introduced. On the bottom, you see culvert with shutters, which allows the local village communities to operate the shutters to let the water flow from one side of the road to the other. You see the ramps which were constructed for access to the paddy fields. You see the ground improvements using geogrids, and then a lot of coconut pilings were used to strengthen. There was weak structures which were replaced by new bridges, and coconut piling, as I mentioned, is a very traditional technology which is very prevalent in Kerala, was used to a large extent. So in terms of cost, as we say that, in the cost, generally, if you look at this, there are three scenarios. One, you have a do minimum where you do less of resilience. The other is only where you focus on asset resilience, and the other where you also build community resilience. Now, when we talk about community resilience, we are talking of features like, those culverts with shuttering arrangements, ramp to the fields, flyovers, because probably you could have raised the road, but probably that would have flooded the community. So in some sections, rather than raising the road, you had to construct flyovers. So generally, the cost of resilience is high in this case, but we can still go with a high cost if the road is of strategic importance, it is having a high climate risk, and so government decided to go with doing this integrated resilience and with the landscape approach. So you look at, per kilometer cost for a do minimum scenario is 7 crore. Vis-a-vis asset resilience building costed almost like another 18.6 crores and another 4.5 crores for community resilience. So this is, a BRT corridor, the example of a BRT corridor where you have done the risk rating of the entire corridor in terms of green, red, and blue. And based on that, the possible technical solutions have been identified, and which is again a hybrid solutions, both hard solutions as well as nature-based solutions. So this is the overall approach generally for road sector. Now let me briefly touch upon the IWT sector.
Others, please mute.
Yeah. So now let me just come to the IWT sector. IWT sector is a very old and a green and reliable mode of transport. It has been a prominent sector since pre-independence, but it has suffered a steady decline over the last 70 years. And then the revival process started from 2016. This is a sector which is also very important for Kerala, with large number of waterways, canals, which can be used successfully. Even there are talks about developing some green corridors in Kerala. So since 2016, there are 105 new national waterways which were added. Big ticket investments in terms of national level programs like NW1, overall development, National Waterway 1, which is Varanasi to Haldia process started. There are investments which are happening in Northeast India on NW2. There are a large number of regional connectivity projects, because waterways can connect Bangladesh. It can also connect to Nepal and Bhutan. So a lot of efforts are being made to kind of have a regional grid. And in 2021, a Vision 2030 was launched. There was a new act, IV Act, Inland Vessel Act 2021 launched, which was almost after 107 years. The last act was 1907. So after 104 years, this new act came. And recently there has also been a launch of subsidy for green vessels. The overall focus of Government of India is to increase the modal share from current 2% to 5% by 2030. So this is very important. This is not only a green mode of transport, but if we can shift a lot of some of the freight traffic from road to waterways, we can also kind of address our mitigation challenges. So in terms of risk-informed planning, if you look at waterways, what are the key hazard types? Basically it faces cyclones, events of floods, droughts, which leads to actually low water scenarios in the waterways, tsunami, earthquakes, which also kind of can lead to disasters during navigation. The various other kind of related disasters are like chemical accidents. A consignment of chemical might kind of sink in the waterways. Terminals impacted by cyclones, by coastal erosion, or riverbank erosion, oil spills, vessel grounding in primarily because most of the vessels that we currently have doesn't have a adequate draft. So there are possibilities of vessels grounding and sinking. Fairway sedimentation is a phenomena which happens after a flood event. So with fairway sedimentation, the cost of dredging goes up, the draft goes up, so the waterways are not navigable post monsoons. So these are some of the major issues. So now the kind of issues that we generally see in the waterways of India are, there is a low draft scenario in the rivers. A lot of bank erosion happens. There is a meandering river, shifting of channels, which also results in low turning radius, makes the ships very difficult to navigate. There are unpredictable weather events, and in absence of night navigation and also the autopilots, this becomes very difficult to navigate. And also the kind of vessels we have. There is a need for a large number of green and resilient vessels, and one last but very important aspect of it, where the entire system resilience comes into picture, is the lack of competent inland vessel staff. So unless we have a competent staff, they cannot navigate these situations. So this is essentially my last slide, and then probably I will open it up for questions and queries to answer. So before building terminals along the river banks, it's very important to stabilize the river bank. So, and here again, the use of nature-based solutions is very critical. It's good to also have green IWD corridors earmarked. Now we are talking about green fuels. We are also talking about efficient designs. Now green fuels, I mean hydrogen, I mean methanol, I mean even the electric ferries. So if we have to kind of provide for that, we have to have bunkering facility across the corridors. So that's very important. So when we have to plan for both for mitigation as well adaptation, this infrastructure not only has to be resilient, but has to be created in that manner so that the green corridors work. There is a long-term need for hydromorphological studies that will generate data for better management of water flow and sedimentation. As I was mentioning that during flood events, the overall sediment flow in the water kind of increases, which settles down post-flood and which increases the need for dredging. Minimum water depths needs to be maintained throughout the dredging so that there is a year-round navigability, and only when there is a reliable navigability factor for the inland vessels, then only the cargo is going to increase. 2 to 5% is not a very easy target. It's quite a lot of work. Nature-based solutions for flood and erosion controls, a lot of bundling, bamboo bundling is used in National Waterway 1, which is in the Ganges. Similar, maybe, there might be certain techniques which are intrinsic to other states like Kerala, which can be used. Low draft climate resilient vessels are something which is needed, in order to navigate low water scenarios, low draft scenarios. So this is something which needs to be designed. But again, this needs kind of innovation in technology, the proportional designs, and this is where you need, government also is putting a lot of investments in new vessel designs, creating hubs and center of excellence in IITs like IIT Chennai as well as IIT Kharagpur. Weather forecasting system is very critical. This will only enable us to understand the overall risks as well as kind of inform the crew about forecasted cyclones and events, flood events, and enhancing the skills and capacities of pilot and crew to navigate safely during extreme weather events are something which is also very critical. This would only strengthen the overall system and the resilience of IWT. So with that, I come to the end of the presentation, and I would be happy to kind of take questions and give a perspective on those. Over. Thank you.
Thank you, sir.
Thank you, Mr. Bose. It was a very excellent talk. Probably a good number of participants are there, and the field engineers are also attending that one. This is a time for interaction.
Sir, this is myself, Wilson Casey. I'm working as a senior scientist in NATPAC. I have one doubt, actually, how we will consider one asset when infrastructure as a climate resilient?
So as I mentioned, this has to be, so as I mentioned, there the concepts that, one, you have infrastructure resilience and, infrastructure for resilience, right? So the concept here is that you have to make the asset resilient. Now, when you have to make the asset resilient, you have to understand the overall risk. Now, and again, the risk is a factor of overall exposure, vulnerability, and, so this this is one part. The other part is about service resilience. Now, why you construct a road? You construct a road to kind of have transport services operating on that road, right? So if the road breaks, there is a break in resilience. So the maintenance of the asset is very important. So here we talk about good asset maintenance strategy and investment in asset maintenance, right? So that is service resilience. Now comes the overall socio-economic resilience. Now, when we are making a road, we are connecting people. Now, if in the process of connecting the people, we make a road which actually floods the neighborhood because the drainage has not been properly accounted for, the entire flow has not been accounted for, or maybe there has been a lot of trees which has been cut, because of which the overall filtration of water is low and the overall surface drainage is more, then we are creating more risk for the community. So here we are talking about community resilience. So in case it's needed, we need to provide flyover rather than raising the the finished road level, increasing the height of the embankment. So that's community resilience. The last thing which is very important is that in the process of building a road, we should not create habitat loss or loss of biodiversity. So the focus here should be more about nature-based solutions, so that we are not overall increasing the climate footprint of any construction. End of the day, in order to create the socio-economic activity, it should lessen the overall our carbon footprint. So use of low carbon technologies, construction technologies, nature-based solutions, use of local materials, that is what should be aimed for. And then if everything has to work, this has to work through a systematic approach. Now, what do you mean by systematic approach? That the engineer should be knowledgeable about all these concepts. Otherwise, it would be very narrowly focused on only infrastructure resilience, on building a a structure which is very important, which is resilient for 50 years, but we leave aside the other aspects, like the community, we leave aside the overall socio-economic aspects. So this is understanding of the entire, and how we can use systems like a climate informed road asset management system would enable us to know the risk more. Unless we know the historical risk and the future risk, we cannot plan for future. So we do know that the climate hazards of the future are unknown, the climate change impacts are unknown, but still we have to design for a optimal resilience. So for that, we need to understand the future risk. So that's the reason, having systems in place are very important. So this is the overall gamut of resilience, not narrowly focusing only on asset resilience, but entire aspect. Yeah.
Sir,
This answers.
thank you, sir. There's a question in the chat box by Dr. Sabida. The question is, you had mentioned about the providing ramps to the paddy fields, but the ramp is blocking the waterway by the side of the road. Is this a sustainable solution, as this may block the natural drainage of the area? Can you provide some light on that?
No, so basically, this was under construction when the photo was clicked. So there would be a kind of cross drainage facility which would be provided in form of a hume pipe culvert. So this was also our observation during the site visit, and I think this has already been done. So the idea is not to create. So that's what I'm saying. A construction should not create systematic risk. The construction should enable the process of reducing the systematic risk. Now, if you are blocking the water, then you are creating systematic risk, right? So you have to create the natural flow of water. So there has to be a hume pipe culvert or some kind of drainage, cross drainage facility along the ramp. Yeah.
There is one more question from Dr. Savita. What measures for climate resilience you will suggest to be included in the DPI preparation of road and waterway projects?
Can you come again, Ashik?
Sorry.
Can you just repeat the questions, please?
What measures for climate resilience you will suggest to be included in the DPR preparation of road and waterway projects?
So this aspects I kind of discussed. So one is the overall macro understanding, right? So the macro understanding would come from the overall system that we put in place. Now, which will give you that, okay, this is a road which we want to develop. This is the macro level of risk, climate and disaster risk this road has. Now we go on ground and do climate risk and vulnerability assessment, where we do very specific, point specific assessment, right? Maybe a 50-kilometer road would have, certain sections which are more vulnerable than the others. So we need to kind of understand those risks, specific risks, and then do a kind of cost benefit analysis of the interventions. Now, and time and time again, I'm trying to point out as the optimal, kind of engineering intervention. Now, when we are talking of optimal engineering intervention, you cannot plan for future disaster events to the extent you want to. So at least actually plan for maybe a return period of 50 years. And if the return period of 50 years is now going to be the, a flood of return period to 50 years is going to be a flood of return period 20 years in future, let's at least plan for that. A 50-year return period of historical nature for the drainage along the road. So this is what needs to be done, and this has to be kind of done with an overall framework of benefit cost ratio, and the benefit cost ratio has to be kind of well justified, and the focus has to be more on hybrid solutions, nature-based solutions to reduce the overall systematic risk. So this should be the fundamental approach and philosophy when a DPR is being done. Thank you.
Thank you.
Hello, sir. Myself, Jinsi. I am an environment expert. Sir, do you have any case study regarding the cost-benefit assessment of various climate resilience options adopted in transport sector in Kerala or anywhere? So this is just for my understanding.
So see, the overall economics of climate adaptation is still not very well understood, and if we narrowly look at only the as I mentioned, damage, loss, and recovery, right? So that's the overall direct output of any disaster event. So like every year you're facing a damage of say 10 crores because you have to reconstruct 5 small minor bridges, some sections of the roads are gets washed away, and so if you do a resilience which kind of cost you 20 crores but will safeguard you for another say 5 years, that means you are saving 50 crores by investing 20 crores. So this kind of leads to a benefit cost ratio of 2.5, and then you can say that this is a well justified investment. But say if you include the other aspects, right, like how the community is benefited, whether because of that the service disruptions that used to happen on that road in terms of the buses flying even during the flood events, if we bring in those benefits, the benefit cost ratio might be much more. So the concepts that I introduced to you are very recent concepts, and not much of analysis has been done. So we have left ourselves only to that, damage, recurring cost of repairs and maintenance. But if we bring in the entire ambit of the benefits of resilience, I think the benefit cost ratio is going to go up. So our attempt for future should be that the DPR consultants gives us a flavor of this. What are the additional benefits? Even if they cannot quantify it, but at least give us some perspective. There are certain things which can be quantified, right? Say, for example, in AC road, I'm not very sure whether it's true or not. What they were saying is that with the operations of this flood gates in the culverts, they can control the water, water to their agricultural fields, and in that way they can also kind of reduce the crop loss. So crop loss is a loss which is a impact of flood, and which you are kind of providing a resilience against as part of this intervention, then you can also create that as a benefit stream for you and have a higher benefit cost ratio. So these are the elements which needs to kind of get factored in where we are building future resilient assets. Yeah, I hope this answers briefly.
Sir, myself,
Hi, sir. Thank you.
Ramisha, from NATPAC. I'm a junior scientist working in water transport. I have a question. You have mentioned a low draft vessel. So what is the main challenge in developing a low draft vessel? Because in the case of Kerala also, in the water transport, the main issue challenging in the water transport sector is the low draft problem. So what is the main challenge in developing a low draft vessel? And also you have mentioned climate resilient vessel. That means that is in the aspect of GHG emission, carbon emission, or any other aspect it is covering?
Yeah, I think a very good question. I think you have observed my slides very well. So when I'm talking about low draft vessels, I'm talking about the climate resilient vessels. So climate resilient vessels, why it's climate resilient? Because low draft is a scenario because of the climate change. Because of low water in the waterways, you have a low draft scenario, and because of higher sedimentation, you have a low draft scenario. So you need low draft vessels to kind of ply. But low draft vessels are difficult to design because of the stability issues, and even the carrying capacity of low draft vessels tends to go lower, right? And low draft vessels tend to cost more. So these are the impending challenges. But IIT Kharagpur is working on low draft vessels. There are some low draft vessels which are designed by DST Germany as part of the National Waterway One Bank initiative. So those vessel designs are available in the IWI website, which is available for free. But again, since this costs more, and overall this, the sector is nascent, and and also there are a lot of financing challenges in the vessels, because vessels cannot be mortgaged like a truck asset which can be hypothecated. A vessel asset cannot be hypothecated. So there are also financing challenges. So even if a low draft vessel which might cost 20% more might face difficulty in financing because of the mortgage issues. So overall, this makes us but again, when I'm talking of climate resilient vessels, I'm talking primarily of low draft vessels and vessels which can resist instances of cyclone with better stability. When it comes to green vessels, basically we are talking about efficient vessels which uses less fuel. That is one. The other is different fuel technologies, low carbon fuel technologies like hydrogen, methane, not methane, sorry, methanol, biofuels, electric and hybrid vessels. So these are the new vessels. Even LNG is maybe in a stopgap approach, but that's what we are seeing as green vessels. But again, for that you need terminals with a bunkering facility, which currently is not this case. Yeah.
Thank you, sir. I think now it's time.
Ashik, one more question. Yeah.
Yes.
Yeah. So thank you, sir, for the nice presentation. I just want one clarification, or I don't know whether the question is correct or not. The topic was definitely on risk-informed transport planning. What will be the maximum risk that we can afford so that we can go for a road development? Because we know that some places, whatever measures we do, and we construct, reconstruct the road, will again fail. And we are not supposed to maybe some kind of recommend some kind of settlements over there. So is there any ultimatum of this risk measurement?
Again, a very good question. I think this is what we are always pondering, right? So basically, there is a concept called stress test. So the concept goes like that. You cannot plan for future disasters all the time, right? So, and there, different climate scenarios will give you of different. Now, if we are acting on our mitigation measures well, then probably we can address the climate change, and probably the kind of impact of disasters or the recurrence of disasters would be low, right? But if we are not acting well on mitigation this disaster, so where we stop? So the concept here is about putting the stress test on a different RCP, which is the representative concentration pathways, say for 4.5, which kind of factors in that the global temperature would be 3 to 4 degrees more than the pre-industrial level. So that's one. And the other is like RCP 8, which is like even more, right? So these are the two scenarios. Like, and then you design for only 4.5 rather than designing for 8, because then that the cost will go high. And in that case, when you design for 4.5, RCP 4.5, there you build in the elements of transport evacuation management, transport emergency planning, so that if the system breaks, how you kind of evacuate the community living on the road, the community which is dependent on the road, how you restore the connections, maybe in a day's time or 2 days time. So again, also it depends on the strategic importance of the road. A national highway road, you have to design for maybe for 8 RCP 8.5, but for a low volume road, it can be still RCP 4.5. So these are some of the aspects that we need to consider while designing the roads in a resilient manner. Yeah.
Thank you, sir. Now, I would like to invite Dr. Shalini, Scientist, Highway and Bridges Division, NATPAC, to deliver the vote of thanks.
Good morning, all. I stand before you with immense gratitude and a sense of fulfillment as we conclude this enlightening technical talk. It has also been noticed that there was many participants across the globe. First and foremost, our sincere appreciation goes to our distinguished speaker, Mr. Indranil Bose. Your in-depth knowledge and clear explanations have left us all with a deeper understanding of the subject matter. We truly appreciate the time and effort you put into preparing and delivering such an engaging talk. Thank you, sir. The inclusion of case studies and interactive discussions has enriched our learning experience and provided us with valuable insights, especially regarding the recent trends and advancements in inland water transport sector. We extend our thanks to all the attendees for your active participation. Engagement has made the event even valuable and created an atmosphere of collaborative learning. We hope that you have found the information presented today, especially on the resilience towards inland water transport sector, both informative and inspiring. We are also thankful to our director, Professor Dr. Samson Matthew, for his constant guidance and support in shaping this wonderful event. As we depart, let us carry forward the knowledge gained and the connections made, especially in this resilience and where we have more disasters occurring, especially in Kerala. So how we can make our roads resilient, let us learn from this experience. May the insights shared today fuel our curiosity and drive for excellence in the field of transportation and for a better resilient transportation. Once again, I would like to express my sincere thanks to Mr. Indranil Bose, the NATPAC team, and all of you for making this technical talk a great success. We look forward to more such enlightening sessions in the future. Thank you one and all, and have a wonderful day.
Thank you. Thanks all.
Thank you, Indranil. Thank you.
Thank you. Boss, you're visiting Kerala, probably you can visit NATPAC also.
Thank you, sir. I'm disconnecting.
Okay, thank you.
Yes.